Hopefully continues that. Okay, let me put this back on there just to get the get it on the video. Test is not till March 5th, so that's a ways away. This is nice. We only have 3 weeks until our next break. Of course, after that, it's a long stretch, but we'll worry about that later. Right? For now, 3 weeks and we get another week off, so that's kind of nice. Today we're going to do long division. Yeah, long division as in what you learned in like 4th grade. 4th grade, I think, maybe 3rd, maybe 5th, somewhere in there. So let's start by doing a 3rd grade problem. Let's do 7,352 divided by 7. And yes, this is a 3rd grade, 4th grade, 5th grade type problem. But the reason we do it is the steps that we use in the number problem will mirror the steps that we do when we get to things like. You're doing remainders. We'll get there. So what do I do first? What am I looking at first on this? Put on your 4th grade hat here. Yeah, how many times does 7 go into 7? Once. And then what do I do? Not drop this 7. We'll drop something in a minute. Yeah, 1 times 7 goes under the 7. And what do we do after that? Then you subtract. Subtract the 7. Again, some of you have raced through, but I want to take this super slow because these steps, again, will be the same that we do later. 7 minus 7 is 0. But then what do we do? You drop 3. Drop down the 3. How many times does 7 go into 3? 0. It's a little overkill here. And then repeat. 0 times 7 is 0. Subtract, we get 3. Bring down the 5. How many times does 7 go into 35? 5. And then subtract again. Bring down the 2. 0 times 7 is 0. Okay, now, Jack, ask your question. Are we doing remainder or decimals? Okay, we're doing remainders or decimals. The answer is neither one. Okay, the first thing you did when you learned this was remainders, right? You just said, oh, there's 2 left over, right? If I took 7,352 marbles and divided them into 7 groups, there would be 1,050 in each group, and there'd be 2 left over. And that's sort of what you stopped, because that was like the first understanding of what division is, like dividing things up into equal groups. Hey, sometimes it doesn't work, you got some leftovers. That was the first go. The second go was, well, like what if we want to divide those 2 leftovers? Like what if we could like chop them up and get decimals? And that's where we would add the 0.000 or however many zeros we needed to add. And sometimes you got repeating decimals, and we're not doing that way either. There's one more thing you can do with this 2. Do you remember what it is? 2/7. So you can get your remainder over your divisor. Use the fancy words. So 1,050 and 2/7. Okay. Yeah, now you're ready to help your younger siblings.
I can teach her how to do that part, so she can do the rest.
All right, now let's do one with letters, variables. M squared minus 7m minus 11 divided by m minus 8. Same kind of process here. So our first question is, well, what times m would get me to m squared, right? Because the lead terms are what matter most. We'll worry about the lesser terms later. So what times m would get me to m squared? M. And I like to keep all my powers in the same column. People will do this part differently. Some will line them up differently. I want to keep them all lined up. So m times m minus 8 So this is the multiply it back step.
Square minus
M squared minus 8m. But what do we do next? Subtract. So we'll subtract, and so it would be minus m squared and then plus 8m.
So m, yeah.
So that will just be m, because that lead term should always cancel out, right? Because you picked m to multiply by m to get to m squared to make that happen. So that lead term should always cancel out. If it doesn't, then you did something wrong. And then negative 7 plus 8 gives me m. All right, what do we do next?
N minus 8 to get to 11.
Well,
I guess 7 n, right? Minus.
let's bring down that minus 11. And then we repeat the process. So what times m would get me to m? 1. So plus 1. Multiply it back. 1 times m minus 8 would be m minus 8. But then what do we do with the m minus 8? Subtract. So change the signs. Again, the lead term will always go away because you picked the right thing to multiply to make that happen. That leaves negative 3. So we could say the remainder is negative 3. The decimal approach doesn't really work here, but what we want to do is the fraction thing. So what's the fraction that I'm left with? Negative 3 over m minus 8. So there's my answer.
I don't think my sister can use it.
Yeah, you can't help your 4th grade sisters with this.
More of it.
Let me write this one a little bit different just to try to throw us off. 42x squared minus 33 divided by 7x plus 7. So who goes in the house? Careful saying that. It is the big one on this one. The first one, right? So 42x squared. Before I write that out, do you notice what's maybe different about this one from the one we're missing that x term? And very much like we did with synthetic division, we need a spot in there so that everything lines up. So let's put a 0x in there. Just to hold the spot. Same process. What times 7x would get me to 42x squared? 6x. All right, why don't you see if you can finish it out from there? Let's do one more together. Then we'll send you on your way toward the assignment. Negative 5k squared plus k cubed plus 8k plus 4. That needs to be in parentheses to make sure all of that is divided by negative 1 plus k. Okay, so which one goes in the house? The longer one, the first one. Probably the first one is the best answer to that, because it'll always be the first one. It might not be the longest one. It might not be the biggest one. It's definitely the first one. And then what's weird about the first one?
It's not set up correctly.
It's not set up right. So I need to put that in order so that everything lines up and works out okay. So this is not, it's a little bit tricky, I guess. Just be careful. So k cubed minus 5k squared plus 8k plus 4 divided by k minus 1. again, they just rearrange things to try to catch us off guard, I guess. All right, so let's see. I guess I should hit pause and let.
Like I said, I'm a couple brain cells down.
Okay, so your assignment today, actually, let's do number 1 together because that one's a little different than the others. So just to mess us up a little bit. Number 1 is actually easier than the others. Any thoughts on what we could do on number 1? Let's factor. Well, crossing stuff out is kind of dangerous. So a couple ways to do that. You could factor out the top and then look for things to cancel, or you could do what Ryan just said, and that's like write each one of them over XY. Either of those is fine. So I'm going to factor out first. So let's see. I can definitely take out a 2. I can take out 1x, and I can take out 1y. And then I got to figure out what's left. So 2y minus. Oh, what do I do if I took? Yeah, make sure there's something there to hold the spot. It didn't just go away. That's minus 1 in the middle. Plus, took the 2, took one of the x's, took the y, so plus x. Over xy. And now you can cancel, because you can cancel things that are being multiplied. So that xy and that xy will go away. And you could leave it factored. You could leave the 2 out front. Or you could multiply the 2 back in there. Either way. The other way that you could have worked at, I'll do it real quick because it's equally valid, is to put each of those terms over xy. And I'm sure it's going to give you the same thing. Let's see. Oops, over xy. So that would be 4y minus 2 plus 2x. And yeah, that's the same thing as if we factored out a 2.
If we leave it as that, that's fine though.
Either one of those are equally correct. Now, number 2 is back to long division. Number 3 is long division with the z squared, so that's a little bit harder than the ones we did. What about number 4? There's something we could do on, it's going to be long division, but we could do something before we do long division that would make life a little easier. Yeah, I can divide the top and the bottom by 3. I can divide everybody by 3. That'll just make my long division a little bit easier. You wouldn't have to do that. You could do it the long way, or before you did that, and still get the same thing. This might make your long division a little easier. Okay, the rest are all similar to one of those. So, assignment today is that worksheet 1 through 8. 20 minutes left. 7 problems left. 3 minutes per problem. Finish before you leave.